you kind of need to know is what an IP address is. And basically what an IP address is it uniquely identifies a host, which can either be a computer, a printer, a server, on the network. And that's made up of 4 octets. So you may see something like this. 192.168.1.1. Each one of these is called an octet. Each octet is made up of 8 bits. So here's our 8 bits drawn out. So the lowest possible number that we can have, this is called binary numbers, and we'll talk about this in a few minutes here. The lowest possible number I can have in an octet is 0. So maybe I could have a 192.0 dot something dot something. The highest number I can have is 255, and that's if all those bits were ones. So I could have like a 192.255.1. So 0 is the lowest, and 255 is the highest. Our subnet mask, if you ever take a look at an IP address on a computer, you're going to see a number that looks like this, and you're also going to see a subnet mask that will probably look similar to one of these. What the subnet mask does is determine what network you belong to. So are you on the BSC's network, or are you on Mid-Continent's network? Whose network are you on? That's what the subnet mask determines. And we'll go through in a scenario here in just a little bit. One other thing I want to bring up is the classes of IP addresses. When they developed IP addressing scheme, this is kind of legacy, but we're going to learn it for this semester. Next semester you'll learn a little bit different way. But for right now, what we do is look at the first octet. And if we're between 1 and 127, we're considered a Class A network. Our default subnet mask for a Class A is 255.0.0.0. So if I had an address that looks like this, 10.0.0.1, I am a Class A address. With a Class A address, the first octet, so our first octet here, is used to determine the network. Okay? The last 3 we have for hosts. So with a Class A network, there's only going to be 128 possible Class A networks in the world. And every single Class A network can have up to like 16,777,000 computers on it. So companies like Apple Computers, they have a Class A. Xerox has a Class A. General Electric has a Class A. Kind of overkill of how many computers you can have on there. Like I said, 16 million. How could you possibly have 16 million computers? But that's what you can possibly have on a Class A. A Class B is between 128 and 191. So if I see the address of 172.16.01, I am a Class B. With a Class B, the first 2 octets are used to determine the network. So the network that this address is on the network 172.16. The last 2 octets refer to a specific host. So for example, this address, 172.16, is on the 172.16 network. The 01 uniquely identifies a specific computer on that network. With me so far? Okay. With a Class B, you can have 16,000 possible networks, and each network can have up to 65,000 hosts. So if they thought 16 million was overkill for you, they'd give you a Class B. When I worked at MDU, they had a Class B type of network. BSC here uses a B type of network. Class C is going to be the most common. That's what we're going to work with today. With the Class C, we have between 192 and 223. So we might see an address like this, 192.168.1.1. Here, the first 3 are used for network, and the last 1 for a specific host. So with a Class C network, there's like 1 million possible networks. There's a lot more networks here instead of the 128 here. 1 million some possible networks, but each network can only have 254 computers on it. Okay? Well, there's really no happy medium. What if I had 300 computers that I needed. Well, they'd give me a Class B, and that's 65,000 computers. That's way overkill. So this system doesn't really work that well. And like I said, semester 2, you'll learn a little bit different way. But for right now, I want you to know this, because it's going to be easier to understand what we're going to do today. Okay? Questions on anything here? Okay, what I said is the subnet mask determines what network you belong to. So let's say that I have an IP address I'm looking at, and the address is, we'll go with 202.4.8.162. And I want to figure out what network this computer belongs to. Well, if I take a look, this 202 falls into which range? Is this a Class A, B, or C? It's a Class C. So I know my subnet mask is now 222.5.0. When I adding these, I'm going to AND these. I need to convert these numbers into binary. Did you guys go over any binary conversions? Oh, the thing? Okay. The easiest way to convert into binary is to draw a little chart here. Draw out your 8 bits. Here's 8 bits, and that equals one of my octets, okay? 8 bits, start on your right-hand side with 1, and just double it as you go to the left. So we have 1, 2, 4, 8, 16, 32, 64, 128. And I want to convert this 202 into binary. So I take a look at 202 and I say, does 128 fit into 202? Yes, if it does, I put a 1 right below my chart. So I take my 202 and I minus my 128. I have 84 left. Then I say to myself, does 64 fit into 84? Yes, it does. It gives me 20 left. And I say, does 32 fit into 20? No, it doesn't, so I put a 0. Does 16 fit into 20? It does. So that's 4. 8 fit into 4? No. 1 fit into 4? Yes. 2 into 0? No. 1 to 0? No. So the number 202 is actually equal to 11010100. The reason why we need to convert it into binary is computers only know electrical pulses. Either the electrical pulse is on or it's off. If it's a 1, it's on. If it's a 0, it's off. So as we got electrical pulses flowing through our networks and things like that, when the computer, router, whatever, sees these electrical pulses, those 8 bits, it knows that that number is 202. Okay? Next thing I need to do is convert 4 into binary. Well, 4 is an easy one. Four is just this. I need a 4, and that's it. So 4 is equal to 1, 2, 3, 4, 5, 6, 7, 8. Geez, I hope my microphone's working. Okay. The number I need to figure out is 8. 8's another easy one. All I need for 8 is just a 1. These would all be zeros. So this is 1, 2, 3, 4, 5, 6, 7, 8. Each octet is always going to be equal to 8 bits, okay? Then I do my last one, 162. Excuse me. 162. Does 128 fit into 162? Sure does. So I take my 162, I minus my 128, and that is 34. Does 64 fit into 34? No. Put a 0. 32 fit into 34? Yes, it does. Gives me a remainder of 2. 16 into 2, no. 8 into 2, no. 4 into 2, no. 2 into 2, yes. And a 0 there. So this is 1, 0, 1, 0, 0, 0, 1, 0. 255s are easy. 255s are all ones. I said before that the highest number I can have is 255, and that's when they're all ones. So 255s is just 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. We're going to show you ANDing right here. Okay? What ANDing does is it determines what network we're on. So you might see a test question like this. If I have the address of 202.4.8.162 with this subnet mask, what network is it on? Well, what I do is I AND them. So I convert them into binary. Oops, this last octet is a 0. I convert them into binary and I AND them. And how I AND them is pretty simple. If I have a 1 and a 1, that's a 1. A 1 and a 1, that's a 1. Anything with a 0 is automatically 0. So a 0 and a 1 is 0, 1 and a 1, 1, 0 and a 1, 0, 1 and a 1, 1, 0 and a 1, 0, 0 and a 1, 0. And what you're going to notice is that anything with a 255 just falls right through. Okay? Anything with a 255 just falls right through. Anything with a 0, I said, are just zeros. 3, 4, 5. 1 and a 1 is 1. 0. See how that just fell right through? Last one here. 0, 0, 0, 0. 1 and a 1 is 1. 0, 0, 0. My last octet here. 1 and a 0 is 0. 0 and a 0 is 0. 1 and a 0 is 0. 0, 0, 0, 0, 0. So anything with a 0 is 0. A 1 and a 1 is 1. Okay? So right here is the network that computer is on. What I do is I convert that back into decimal. And the easiest way to do this is just write this right over your chart. So here I have a 1, 1, 0, 1, 0, 1, 0, 0. A 128 and a 64 is 192, and a 16 is 208, and a 4 is... Wait, I was off, wasn't I? 192 and 16 is what? How come I'm so off with this? It's 192, that is 208, that's 212. I'm off here with this. My 202 is not correct, is it? 202 in binary is 192 and an 8. 192 and an 8, which is 200, and a 2. Wait, how did I get that? That is 202. So in this one would be 11001010. Sorry about that. So I write that right over the top here, 11001010. That's 192, and 8 is 200, and a 2 is 202. Or like I said, these just kind of fall through. This here is a 4. This here is a 8. And all zeros is 0. So the network that this address belongs to is the 202.4.8.0.
IP plus the subnet.
IP plus the subnet, well, IP ANDed with the subnet is the network. Why this is important is because that's what a router does. When a router gets a packet and it sees, okay, I'm trying to go to this address. Well, first I need to know which network to go to. So it figures out which network to go to. Then once it gets to that network, then it needs to find the specific host. And this last octet in the class C is for the specific host. Okay? Make sense? Everyone's with me? Okay. Well, that's how you would do a question like that. What network is it on? And them together.
do all of that? Or does the router, the Cisco software, take care of some of that?
The router Cisco software would take care of all of that for you. Really, the only reason why I show you that is because you'll see questions like that in the test. Normally what you can do is you just can kind of take a look at an address and say, well, I know what networks that one's going to be on. Like if I give you a 192.168.3.2 with this subnet mask, I can just take a look at it, and I know that anything with a 255 just falls right through. Once you do a bunch of these, anything with a 0 becomes 0. So this is the network that it's on. Okay? If I give you an address of 172.16.3.4 with a double 255, I'm trying to figure out what network that's on. I can just see that it's a 172.16.0.0 network. And this identifies the specific host on that network. Okay? Okay.